Hello बच्चों, let's read this question. A metallic rod of mass per unit length 0.5 kg per meter is lying horizontally on a smooth inclined plane which makes an angle of 30 degrees with the horizontal. The rod is not allowed to slide down by flowing a current through it when a magnetic field of induction magnitude 0.25 Tesla is acting on it in the vertical direction. We need to find the current flowing through the rod to keep it stationary. ठीक है बच्चों, let's draw this scene. We know there is an inclined plane with the base angle given as 30 degrees. We have a wire over here on the inclined plane, and there is a vertical magnetic field of magnitude b. ठीक है, तो we know the mass is going to pull it downwards by some force mg. We're assuming this wire length to be 1 unit. All right, and now we want this wire to stay in equilibrium, that is it has to be here, it should be stationary. So there is going to be a normal force in this direction, so there is a net force in this direction, right? Since this component is going to get cancelled, there is a net force in this direction, so we need a force which can counter this. Since the force due to a magnetic field on a current carrying conductor will be perpendicular to the magnetic field, we can have the force in this direction. We know all the three things: the current, the direction of the current, the direction of the magnetic field, and the direction of the force due to a magnetic field is going to be perpendicular to each other. Using the right hand thumb rule, the Maxwell's right hand thumb rule, we can determine the direction of the current. We can see that if the current is coming towards the user, that is the current I is going to be outwards towards the viewer, then the force will be towards left as shown in the diagram. So now we need to balance the forces. So we have a force B, this is a free body diagram of this point. We have a force mg, and there will be a normal force in this direction. So we need to balance the force which is perpendicular to the normal force, right? So since the base angle is 30, we can say this angle is also going to be 30 since it's the same angle. And this is a 90-degree angle. We know this is the plane of the inclined plane. So this is going to be 90 degrees. This whole angle is going to be 90 degrees. 90 minus 30, this angle becomes 60 degrees. And again, FB and MG are also at 90 degrees. So this angle becomes 30 degrees. So we can take the component of force due to the magnetic field and the gravitational force along this line, the inclined plane. So we will get FB cos 30 is going to be equal to mg sin 30 ठीक है बच्चों, तो यहाँ पे हमें इसका वैल्यू पता है. We know FB is equal to nothing but IL cross B, but in this case L and B are in perpendicular direction, so cross product yields nothing but LB. So let's substitute this over here. We will get ILB cos 30 is going to be equal to mg sin 30. ठीक है बच्चों, on rearranging these terms we can get I is equal to nothing but m by L multiplied by g sin 30 divided by b cos 30. So let's substitute this value. M by L is nothing but the mass per unit length, so we can write this as 0.5. The value of g we know is going to be 9.8. Sin 30 is 1 by 2. We know the value of b is given as 0.25, and cos 30 is root 3 by 2, which simplifies to 0.866. So on cancelling 0.25 and 0.5, we get a value of 2, and 2 and this 2 can get cancelled. So finally we have 9.8 divided by 0.866, which on solving gives the value around 11.32 amperes. ठीक है बच्चों, so this is the answer which we were looking for. Let's check the options. 7.14 is the first option, this is incorrect. 5.98 is also incorrect. 14.76 is incorrect. Option D says 11.32, so this is the right answer. I hope you understood the solution I have given here. Final answer is option D. Thank you very much.